So in this reaction, we go from an amide to a nitrile. And when I first looked at this reaction, when I was first learning this organic chemistry reaction, I looked at it and I was like, huh? That's used for turning a carboxylic acid into an acyl chloride. So you'd think it would do the same thing, but it doesn't. It turns that amide into a nitrile, and that's because it reacts very differently. Nitrogen's a different species, and we'll see that in the mechanism. So let's actually begin here. So we have NH2, and the first step is, this is what SOCl2 looks like, a carbonyl. So what happens is the nitrogen is going to initiate this reaction, and it's going to push electrons onto the nitrogen-carbon bond. And we have some lone pairs on our oxygen, so it's going to push electrons up, giving oxygen a negative charge, which then causes these electrons to attack the sulfur, and thus putting a charge on our oxygen on the SOCl2. And then we have so notice that our oxygen has a negative charge and our nitrogen has a positive charge. So we want to neutralize that here. So we could do an intramolecular attack on that, where this oxygen, like if we were to flip this bond, it could attack. But it could come from another molecule of this. It really just depends, but we'll keep it as the intramolecular attack, where we have this occur. And then NH double bond, oxygen. OH, same thing happens again. We're gonna kick this group off. All right, and then we get our protonated nitrile. So our last part is just simple deprotonation, and you're like, okay, what's gonna protonate that? The only thing we have is SOCl2, so it has to come from SOCl2. The question is, how does it do that? Well, remember, we just kicked that group off, and if you remember, it now has a negative charge on it, right? Because we dumped electrons onto it. So what happens is that we are going to just simply pick up a proton. And it's not favorable for this to fill in, because then sulfur would have a negative charge, and we know that oxygen would rather have that, so because it's more electronegative. So it picks up the hydrogen, dumps electrons onto the nitrile, and we're left with our final nitrile product. That's the mechanism. I hope you guys enjoyed.